Hello, welcome everyone. Today we will be looking at the application of the properties of different solids in relation to their uses in life. Please stay tuned and enjoy the lesson. Now, what are solid materials? Solid materials are objects that have fixed shape and volume. Solids maintain their shape and volume under normal conditions. They have strong force holding their atoms, ions, or molecules together in a fixed arrangement. This force is called intermolecular force. Let's take a look at some structures in our environment and the solid materials they contain. Take a look at the buildings around you. They are made of solid substances like concrete, steel, wood, bricks, blocks, etc. What about the glassware or glass products in your home? They are made of sand. Sand is one of the raw materials which is melted to make glass products. Let's consider vehicles. Every vehicle definitely is made up of solids like metals, glass, plastics, leather, cushion, connecting wires, etc. Plastic materials. Examples of plastic materials are plastic bottles, plastic bowls, plastic spoons, plastic table and chairs, etc. In general, plastics are made up of solids like polyethylene and polyvinyl chloride, PVC. Bridges are also made up of solids like steel, concrete and stone. Some groupings of solid materials. Solids are grouped into many classes. Let's take a look at some of them. Let's start with polymers. Polymers are large molecules made up of repeating subunits called monomers. They are flexible and have a high strength-to-weight ratio. Examples are polyethylene, polyvinyl chloride, or PVC. Let's look at crystalline solids. These are solids that have its particles showing a well-organized geometric shapes. This means that their atoms or molecules are well arranged in a repeating manner. Examples of solids that are crystalline in nature are table salt, sugar, diamond, quartz, etc. Another group of solids are metals. They are neither polymer nor crystalline. Examples of metals are iron, nickel, copper, aluminium, zinc, cobalt, etc. Metals have some unique properties. Examples are heat and electrical conductivity. This property means that metals can easily absorb heat and electricity can also pass through it easily. It is because of this property that metals are used for making electrical wires, power transmission cables, electronics, and heating appliances. Magnetic properties of metals. Iron, nickel, and cobalt exhibit magnetic properties. Cobalt, for instance, is naturally magnetic. This means that it can attract other magnetic substances. Metals with this characteristic are very good for making electrical motors, generators, transformers, and magnetic storage devices like computer hard disk drives and floppy disks. Reflectivity. This is the ability of metals with smooth surfaces to reflect light and heat. Example is steel. Metals with this property is used for making mirrors, reflectors, and solar panels where efficient reflection is required. High melting and boiling points. Most metals have high melting and boiling points, allowing them to withstand high temperatures. Metals with extremely high melting points, such as tungsten and molybdenum, are used to produce materials capable of withstanding very high temperatures like jet engines, cutting tools, spacecraft parts, radiation shields, etc. Metals with high melting points are also used to make crucibles and molds for casting other materials such as ceramics and alloys. The crucible or mold remains stable and does not deform during casting. Other metals, such as lead, with lower melting points, are used in soldering to join different components. Density. The density of metals refers to how much mass is packed into a given volume of the material. In simpler terms, it is how heavy a metal is. Metals usually have high densities which increase their mass and make them strong. In military and defense applications, high-density metals like depleted uranium are used in making armor-piercing ammunition. Now let's take a look at some experiments. Experiment to demonstrate the magnetic properties of different materials.
Magnetic materials, metals and magnets. How can we determine which metals are magnetic and which are non-magnetic? Here we have scissors, a key, a $50 coin, a paperclip, a safety pin, and a ball of aluminium foil. They're all made of metal. Let's use the U-shaped magnet to determine which objects are magnetic. The scissors are magnetic. I thought the key would be magnetic, but obviously it's not. The $50 isn't magnetic either. The paperclip is magnetic. So is the safety pin. The foil is not magnetic. As we can see from this simple demonstration, some metals are magnetic and others are non-magnetic. Generally, objects that contain the metals iron, nickel, and cobalt are magnetic. Objects made of aluminium, brass, copper, gold, and silver are non-magnetic. Thanks for watching. See ya!
Experiment to show densities of various metals.
Okay, let's talk about density. So density is a formula that you have to calculate. It's a ratio of mass to volume. Now mass is how much stuff is in something, and it's measured in grams. By the way, 1 gram is about a large paper clip. Volume is a measure of the space something takes up, and it's measured in cubic centimeters, and that's a cubic centimeter. So I have these 5 cylinders of 5 different metals here. And the question I have for you is, what do we know about the density of these items? Well, let's first look at the volume. Since density is mass divided by volume, let's take a look at their volume. Now the diameter of these cylinders is the same, but what is different is they have different lengths. So what can we say about the volume of all of these? Well, we can say the volumes of all of them are different, okay? So in the equation, this would be different. The volumes would all be different. The next thing we should talk about is the mass. Okay, well, to measure the mass, you need a balance. I have a digital balance right here. So let's turn it on. And it's a little hard to see the number. Oh, it's still turning on. There we go. Okay, let's start with the longest one, which is a metal called aluminum. And it looks like it has a mass of 29.12 grams. All right, this one is tin. This one has a mass of 28.99 grams. So it's very similar in mass. This one is zinc. It has a mass of 29.20 grams. Okay, that's pretty similar also. And copper is 29.13 grams. And then lead right here, the smallest one, is 29.11 grams. So what we see from the mass of all of these is they are all about the same. The mass of all of these cylinders is about the same. Okay, so the question is, if the masses are all about the same and the volumes are all different, what does that do to the density? Do you think the density is the same for all of these? Or do you think the density might be different? Well, actually, because the masses are the same and the volumes are different, if either one of these is different, then the density is different. So the density of all of these metals are different. And I looked it up on a chart, and I can show you right here. So let's start with the heaviest. The heaviest is the lead. So lead is pretty dense, and it has a density of 11.35 grams per cubic centimeter. A little bit lighter, but still pretty dense than lead, is copper. Copper has a density of 8.96 grams per cubic centimeter. Now going lighter still, we have tin, like in a tin can. This has a density of 7.31 grams per cubic centimeter. Going lighter still, we have zinc. Zinc is 7.13 grams per cubic centimeter. And the lightest of these metals is aluminum, with a density of 2.7 grams per cubic centimeter. So therefore, the densities are all different, and it's simply because the volumes of them were different, but the masses were all the same. I hope you learned something. I hope it helps. Thanks for watching. Have a great day, guys.
Experiment to show electricity conductivity.
In this video, I am going to demonstrate some matters which are good conductors of electricity and some other matters which are bad conductors of electricity. Good conductors are those materials which allow electricity to pass through them easily, whereas bad conductors are those materials which do not allow electricity to pass through them easily. For this demonstration, I have taken cardboard, battery cell, wire, bulb, copper, aluminium, graphite, iron, steel, wood piece, rubber, plastic and glass. And also I have taken liquid matters like salty water, tap water, lemon juice and vinegar. For this demonstration, we have to make a circuit. For this, we have to connect two wires to the battery and the bulb, and remaining two ends are free. When we connect these two ends, the circuit will be completed and the bulb will glow. Now, I am going to check whether these matters are good conductors of electricity or bad conductors of electricity. Here is steel. I am connecting the both terminals of a wire to the steel. Whoa, the bulb glows. This shows that the steel is a good conductor of electricity. Now wood. No, it is a bad conductor of electricity. Now iron. Oh, the bulb glows. So iron is a good conductor of electricity. Now rubber. Oh no, the rubber is a bad conductor of electricity. Now graphite. Graphite is a good conductor of electricity as the bulb glows. Now plastic. Plastic is a bad conductor of electricity. Now aluminium. Aluminium is a good conductor of electricity. Now glass. Glass is a bad conductor of electricity. Now copper. Copper is a good conductor of electricity. Now, let me check the liquid matters. Vinegar. Immerse two terminals in the vinegar. Oh, the bulb glows. This shows that vinegar is a good conductor of electricity as it is an acid. Now, lemon juice. Immerse these terminals in the lemon juice. Oh, the bulb glows. This shows that lemon juice is a good conductor of electricity as it is an acid. Now, salty water. Immerse these terminals to the salty water. Here, the bulb glows. This shows that salty water is a good conductor of electricity because salt molecules are made up of sodium, iron and chlorine ions which are freely movable. Whereas in salt, it is not a good conductor of electricity because the sodium and chlorine ions are not able to move freely. Now tap water. Immerse this terminal to the tap water. Here, the bulb glows slowly. This is because tap water contains many irons and impurities. Thus, tap water is a conductor of electricity. If tap water contains only irons, it is a good conductor of electricity. Thus, the summary of this demonstration is, among all these matters, wood, rubber, plastic and glass are bad conductors and remaining all are good conductors. Thanks for watching.
Uses of polymers in relation to their properties. Strength and durability properties. Many polymers strong and durable. Durable means it can withstand wear and tear, corrosion, deformation, and different temperatures. This is why polyethylene, PE, and polypropylene, PP, are used for making packaging and construction materials like PVC pipes. Aramid fibers, which is also a polymer, is used for making bulletproof vests. Flexibility and elasticity. Some polymers are very flexible and elastic, which makes them to bend and stretch without breaking. Such polymers are used for making flexible packaging films, elastic bands, and soft-touch materials like rubber. Thermal stability properties. Some polymers have good resistance to high temperatures. Examples are polyimides. Because of this, they are used for making insulating wires for aerospace and electronics appliances. They are also used for producing protective clothing for firefighters and industrial workers. Chemical resistant properties. Some polymers are also resistant to various chemicals and acids. This makes them suitable for corrosive environments. Such polymers are used for making pipes and tubes in industries where corrosive fluids or gases are transporting. They prevent leaks, corrosion, and contamination, making them suitable for applications in chemical processing plants and laboratories. These polymers are also used in coatings and paints to enhance their durability and resistance to chemical exposure and environmental factors. Electrical insulation properties. Some polymers can be used as excellent insulators to prevent the flow of electricity. As such, they are used for making insulating coatings, cables, and connectors. Transparency properties. Some polymers are transparent and they are used for making panels, lenses, and signage. Water resistance properties. Some polymers have very good resistance to water absorption, making them ideal for applications that involve contact with moisture. Example, polyethylene terephthalate, PET, is commonly used for making beverage bottles due to its water resistance and transparency. Biodegradability properties. Biodegradable materials are materials that can be broken down or decay naturally by decomposers and environmental processes over time. These materials are typically made from organic substances. They are more environmentally friendly than non-biodegradable materials. Biodegradable polymers are used for making absorbable sutures. These are threads used in the hospitals for stitching wounds. They dissolve or break down after some time, so they don't need removal by doctors. They are also used for making packaging materials. Bonding properties. Some polymers have a very strong adhesive property. This makes them bond well with various surfaces. So they are used for making adhesives or glues, tapes, and sealants. Now let's look the properties and uses of crystalline solids. We will look the properties of two crystalline solids, which are glass and marbles. There are different types of glasses for different uses. The different types of glasses are due to the different materials used to make them. Some types of glasses are soda-lime glass, borosilicate glass, lead crystal glass, fused silica, and aluminosilicate glass. It is used for making windows, bottles and jars, and scientific glassware or glass instruments, laboratory glass instruments, chemical storage containers, and pharmaceutical packaging, where the material needs to withstand corrosive substances. It is also used for making cooking utensils, fine glassware, chandeliers, and decorative items. It is used for lenses, mirrors, and precision optics in scientific instruments, for making smartphone screens, armored vehicle windows, and spacecraft parts. Before I sign off, let's look at a summary of today's lesson. Solid material are objects that have fixed shape and volume. Solids are grouped into many classes like polymers, crystalline solids, and metals. Each of these solid types have special properties which makes them suitable for specific purposes. For example, some polymers are so durable and tough that they are used for bulletproof vest. Some crystalline solids have beautiful natural colors so that they are used for decoration in the house. Metals, on the other hand, have high heat and electrical conductivity, so they are used to make electrical wires and cooking utensils. I hope you have enjoyed the lesson. Repeat this video as many times you need to so that you can understand it. Thank you for watching.